Everything you've heard in this series so far has been words, decisions, documents, promises. And you've watched every dead MMO make promises like these. Words are cheap. These frames aren't. They're renders of a stock character, a stand-in, not the shipping art, playing real animations inside the real game engine, produced end-to-end on July 15th, 2026, on openly licensed tools and assets. That isn't concept art, and it isn't a mock-up. It's the test that decides how every character in this world will move. Rendered evidence, not a promise. This is the episode where a question that could have rewritten the whole asset plan went on trial, and the standard for the verdict is the title, Screenshots, or It Didn't Happen. From day one, this project's roadmap has carried a small number of formal go, no-go gates. Questions so load-bearing that if the answer is no, the plan doesn't get adjusted, it gets rewritten. This one was written in June as, Prove the rig retargeting pipeline. In plain English, prove we can borrow animation. A 3D character is a mesh, the visible skin, wrapped around a rig, a digital skeleton of named bones that animation actually moves. Here's the problem. Animation is authored for one specific skeleton. Darkerlight's asset strategy leans on openly licensed animation packs made by different creators, so the pipeline is what has to work. And those skeletons are incompatible. One family has a full set of bones, individual fingers, a real neck and shoulders. Another has a fraction of them, mitten hands, different names, and joints that twist along different axes. Animation written for one is gibberish to the other. Retargeting is the craft of translating motion across skeletons, and it's notoriously fragile. The classic failure modes are twisted wrists, sliding feet, weapons floating a meter from the hand. And on this project, the whole pipeline has to run start to finish from a script. That's the honest bar. It works scripted, or it doesn't. If retargeting failed, every character would need purchased or commissioned animation, one skeleton at a time, a cost that quietly rewrites the entire economics of the game. That's why this one was answered first, not because it was the hardest thing to attempt, but because it was the most expensive thing to get wrong. The trial ran under handcuffs, and they're the interesting part. Rule 1. Openly licensed assets only. A public domain style license, no strings. Not because anything else was off the table, but because it keeps the experiment clean. If the pipeline only worked on one vendor's files, we'd have proven nothing about the pipeline. Rule 2. Every step is scripted and repeatable. The tools install from a command. The inputs download the same way every time. Even the asset storefront's download flow is automated, so a fresh machine fetches every input identically twice over. The game engine Darkerlight runs on, and the 3D suite the bake happens in, both install headless. No window, no interface, run from the command line. Why so strict? Because anything that has to run on every asset forever has to run the same way every time. And the only way to prove that is to take the hand adjustments away. And it buys the thing that matters more than speed. The whole run is repeatable on demand, not frozen. The tools moved under us once during this very run, and the code had to change to keep up. But every claim in this episode can be regenerated from scratch by running the scripts again. And when the ground shifts, we find out immediately. The architecture is one decision wide. Pick a single canonical skeleton, one official rig every character in the game will share, and translate everything else onto it, once, at the door. The engine itself never retargets anything, receives characters already speaking the house language. The candidates were the two openly licensed rig families. We made the choice on evidence, not preference, and the richer rig won. Full fingers, a proper neck and shoulders, and bone names matching a widely used industry convention, so future paid packs map onto it cheaply too. Picking the sparser skeleton would have thrown away finger and shoulder detail from every richer source forever. That choice, canonical skeleton locked, is now a permanent, dated decision in the project's records. Then the bake. A script drives the 3D suite, windowless. It refits the canonical skeleton to the knight's proportions, reattaches the knight's skin to it, and then the hard part. Transferring animation by replaying each source bone's motion in world space, frame by frame. That's exactly where retargeting usually breaks. Here it held across both rig families. 13 clips baked onto the one skeleton, weapons tracked through fast attacks, then sampled and inspected at the moments most likely to expose a bad translation, including the 3 gesture gaps from last episode's audit: the point, the horn call, the knife flourish, built by retiming and layering existing clips, exactly as the audit predicted they could be. Out comes a single clean character file. The engine imports it, again scripted. Then a capture scene plays all 13 clips and saves 104 frames. That last step is the one honest exception to the no interface rule. Drawing pixels needs a real screen, so the run opens a window, drives it, and closes it again. Scripted start to finish, just not invisible. A server would do the same thing on a simulated screen. That plumbing isn't written yet. One more detail had to survive contact: weapons. Sword, dagger, and bow attach to the hand bones and get tracked through fast attack motion, precisely where sloppy retargeting betrays itself. Look at the frames. Through the whole swing, the sword stays in the fist, the attachment holds. The angle it sits at is still a rough constant shared across every weapon. Giving each weapon family its own authored grip is real work, and it's still on the list. What's proven here is the mount, not the polish. So how does anyone know those frames aren't cherry-picked luck? Nothing here ships on a look, not even a good one. Every frame gets checked cold, and then the file itself gets tested in code. First, we reviewed the frames cold, 14 representative frames, every clip, 2 camera angles, checking that the walk actually strides, the dodge roll reaches the ground and recovers. The bow draw reads as a draw, with none of the classic corruption tells, mangled feet, twisted hands, floating weapons. It passed. Then the second layer, an automated self-test in code, asserting hard facts about the exported file, the exact clip count, the exact bone count, and motion floors. Checks that specific bones genuinely move during specific clips, so a broken bake that renders a beautiful statue fails loudly. Here's the honest beat, and it's the one that matters most. While we were writing that self-test, one assertion named the wrong arm. The check went red. The animation itself was perfect. The test's own assumption was wrong. We investigated the mismatch, reran the numbers, and the assertion, not the artwork, turned out to be the broken half. We fixed it, and only then did the check go green. Understand what that small failure proves. The test caught the mistake before anything shipped. A claim written into a check didn't match the animation. We reran the numbers, and the check went green only once the claim matched reality. That's the point of writing the claim down in code, instead of trusting a look. A test that only ever goes green is decoration. This one bit, it just bit the wrong half. Nothing here goes green until the claim and the artifact agree. And that's the standard whichever one turns out to be wrong. The run surfaced one more truth nobody asked for. Last episode's animation audit took its openly licensed count from one vendor's own online clip list. Counted from the real downloaded files instead, that vendor's openly licensed set is 86 clips, a fraction of what the audit had been working from. The online viewer, it turns out, quietly shows the paid library too. The consequences were checked the same day. We reran the coverage check against the 86, clip by clip, over the motions the design actually needs. It holds. The plan still needs no custom commissions. But the margin was thinner than claimed. And on screen, you can see exactly where, which is exactly why a paid animation pack already sits in the next phase's plan. The correction went into the audit as a permanent banner, not a quiet edit. A project that verifies everything doesn't get to be right the first time, every time. It gets something better. It finds out. One bonus finding rode along, an open aesthetic question. The stock knight is stylized and squat, so would the pipeline hold up on realistic adult proportions? Rather than debate it, the run was pointed at an adult-proportioned mannequin. Same skeleton, same clips, both bodies. And the comparison got rendered. Silhouettes side by side, answered in minutes. Some questions stop being arguments and become receipts. The verdict, recorded July 15th. Go. The gate passed early on real files, ahead of the work that now depends on it, and finished the same evening. The whole proof, scripts, evidence frames, the tests, is committed as a seed the build inherits on day one, and the canonical skeleton is no longer a plan. It's locked, with the evidence table to show why. One of the other June gates is still open, proving the terrain runs smoothly in an ordinary browser tab. We won't claim it until it passes on camera, the same way this one did. That's a later episode, and it only exists once the proof does. When this series started, this was a premise: an independent studio in Canada, holding itself to one rule: prove every claim on camera before it makes it. Checked by tests, it isn't allowed to skip. Now it's a character, walking, with a paper trail. The design has been argued down to decisions we're willing to be held to. The pipeline that mattered most is proven. What comes next has no shortcuts. The world is being built now, milestone by milestone, each one with receipts. The game is Darkerlight, screenshots or it didn't happen.